In the first tutorial, we went in and we did a model of this head gasket. So the way that we structured our model, as you can see here, is we made a single sketch, and it had the two circles in it, the outside circle and the inside circle. And then we finished that sketch and we extruded the washer shape. But that's not the only way we could have structured this model. For instance, we could have done a sketch for the outside, extruded that, and then put a separate sketch on and extruded the inside out separately. We could also have gone in and sketched a rectangle and revolved the rectangle around this axis. There were several other ways we could have done that. We could have gone in and we could have said insert design feature cylinder, and then we could have put a hole in the cylinder. Well, the reason we chose the method that we did was not just haphazard. Okay, there are actually some guiding principles that led us to make this choice. Most of the time when you're modeling, you'll have a choice. You'll have a lot of different ways that you can approach a model and the way that you structure that model. The right way and the wrong way really boils down to a thing called design intent. And then second to that is perspicuity. So let's talk about what both of those things are. So the design intent means that you structure your model based on the intended purpose and function of the actual design, the actual working part. So for instance, if we have this metal bracket with 4 holes, let's say, punched into it, and let's say that this 6 inches was going to change and it was going to become, say, 8 inches. Would we expect it to change like this? Let's go down 2 inches. Or would we expect it to change like this? Should the holes stay together as a group, or should the holes move when the plate grows and shrinks? Well, the answer to that is it depends on what these holes are there for. Okay, so if this were, say, an engine mount, and all 4 of these holes mounted to the side of an engine, and we adjusted the height of the mount by adjusting this 6 inches, then we would expect the holes to stay together, and we would expect the plate to be modified separately. If this plate were some kind of bracket and it attached to 2 separate rods, then we might expect it to be modified like this. So that's design intent. The design intent means that we structure our model to behave in a way that's consistent with the actual purpose of the part. One important reason that we didn't do the revolve method, that is this one where we sketch the rectangle and then revolve the rectangle around, one of the main reasons we didn't do that is because if you look at the rectangular view here, we have a reference dimension on there. Okay, so the reference dimension tells us this is sort of a for your information dimension on here. That is not controlling any of the geometry of the finished part. We can't reject this on inspection of this dimension. It carries no weight. And so it's a less important dimension than these other more important driving dimensions for the diameter of the outside and the diameter of the inside. So we structured our model based on the important dimensions. The second part of what's driving our decisions is a thing called perspicuity. The idea of perspicuity is that your model is plain and clear and easy to edit. Let's say that this head gasket needs to change. Say maybe the outside diameter needs to change. Well, what would be ideal is if we could figure out very easily and quickly how to change that diameter. Now, the person that's looking at this sketch or this model might not be the same person that modeled it. Anybody needs to be able to take this model and figure out how to go in and change those dimensions. This is a pretty simple model, so it's pretty easy to figure out where those dimensions would come from. We go to edit the sketch, and we can see plainly the dimensions that are on our print are actually here on the model itself. That's a really good way to work. You want to make sure that your model is consistent with the drawing in terms of design intent, and it also needs to be clear. It needs to be easy to find out how it's structured and how to make the change. So when you're modeling, you want to keep those two things in mind. Does the structure of my model reflect the design intent of the part? And also, is it clear? Is it going to be easy for someone else to come in and make a change?